Now we are going to start with the chapter that is the thermodynamics, right. That means in this we are going to study about all that energy changes that occur around us. As you all know that when we see a chemical reaction, in some of the chemical reaction energy is being absorbed, right, and in some of the chemical reaction we see the release of energy, right. So that means chemical reaction occur at the cost of energy. That means either the energy is absorbed or the energy is released. That means the energy changes take place, right. Likewise, when we use a certain form of energy, like when I switch on the light, then what happens? Electric energy gets converted into light energy. That means we get to see energy transitions as well, it means transformations, right. That means one form of energy can be converted into another form. All that which is related to the energy is we are going to study in this topic, that is the thermodynamics, right. So thermodynamics we can say is a branch of chemistry, that deals with the study of all forms of energy, energy changes and also energy transformations. That means we will see that energy is being converted from one form to the another form. So this is what is called as thermodynamics, right. So as you all you must be thinking that where we are using this thermodynamics in daily routine, does it have any significance in our daily routine? Yes, it has. See, when you are running, like as we all know that on road we get to see many vehicles running, right. So that means with the modernization, there's technology is increasing. That is why we get to see different type of cars, right. We have Audis, we have BMWs, we have trucks, we have Jeeps, we have variety of vehicles. You know that how that vehicle can move, like what is the factor that make it move? It is the combustion of the fuel, right. So what happens when the fuel gets burned? It produces energy, right, and that energy is being used to run the vehicle. So that energy which is liberated due to the combustion of fuel is again concerned with the thermodynamics, right. Moreover, see, just take an example of the home. You relish eating pastas, Maggies and all, right. It is not possible to cook all those things without the use of LPG, you know that, right. So that means what you are doing then, you are using an LPG where the chemical substance just get burned and it produces the energy, and that energy is something used to cook your favorite things, right. So there also thermodynamics is involved, right. So that means thermodynamics, wherever in the universe, whatever the energy changes are taking place, energy transformations are taking place, energy is absorbed or released, that is all is concerned with the thermodynamics, right. So this is what we are going to study in this unit, that is the thermodynamics, a branch of chemistry that deals with the study of all forms of energy, energy changes and energy transformations. See, it doesn't deal with you can say that it do not provide us the detailed information about all forms of energy, but here I wrote this all form of energy because we'll get to see energy change or energy transformation when we are just aware of the different forms, right. So that is why I wrote here. Otherwise you can also say that the thermodynamics is a branch of chemistry that deals with the study of the energy changes as well as the energy transformations which are taking. So before we take up this chapter, I just want to make you familiar with certain terms, because that terms I am going to use in this chapter again and again. So you should be well versed with those technical terms. So let us see that what are actually those terms. So the first term is system. So what is called as system? System is actually a part of universe which is under investigation. System is a part of universe which is under investigation. Suppose I just want to know if, the properties related to this marker, right. I have this marker and I want to know the properties related to it, right. So that means this constitutes my system, because this is under investigation. I am just going to look at it, that what happens when I heat it, what happens when I cool it, right. So I just want to you can say have a look about the properties related to this marker. So this marker is my system. So you can say system is a part of universe. System is a part of universe which is under investigation, means which we are going to observe, right. So that means which is under investigation. Apart from system, everything which is around that is surrounding. Apart from system, everything that is present is surrounding. Suppose I told you that this is my system, I am going to study about it, right. So apart from this, everything which is around this marker, everything like the chair, table or the atmosphere, everything which is apart from, means leaving this marker, whatever is surrounding this is called as its surrounding. So that means surrounding is the part of universe, obviously the other than system. Means we leave system, and apart from that, everything which is around that system is called as surrounding. So this is what is the surrounding. And you know, system and surrounding, when they combine, they give rise to universe. So the component of universe is two, that is the system which is under investigation, second is the surrounding, that leaving behind system, everything, that is called as surrounding. So system plus surrounding, that makes the universe. Now see, like I have told you that this is a marker, right. So that means it has you can say a layer around it which is separating it from the surrounding, right. So that is called as boundary wall, that is called as boundary wall. So we have another term, that is boundary wall. So what is the boundary wall? Boundary wall is that surface which is separating the system from the surrounding. Boundary wall is that wall which is separating system from the surrounding. So what we get to see? We get to see different types of boundary wall. So what boundary wall? Like the real boundary wall and the imaginary or a virtual boundary wall. Like if I say that suppose I have a beaker, and in this beaker I have a water. So this is my system, this whole beaker, right, and this around that is a surrounding. So this outer layer of the beaker is a real boundary. You can see that separating water from the surrounding. So it is something real boundary which you can observe with the help of the naked eye, right. But when I talk about this marker, suppose I am going to heat this marker, so that means the energy is going to rise from it, right. Suppose I say I have a marker here, and when I heat it, all the energy, suppose I say that when I heat it, all the energy spread up to this region. So what will I say? That yes, this is a marker, this is my system, apart from that this is a surrounding, but we do not get to see any kind of boundary separating it, right. So but there is a boundary that separates this system from the surrounding, and that the imaginary boundary which you cannot see with your eye is called as imaginary or a virtual boundary. But there is always a boundary separating system and the surrounding. Now we have when we talk about walls, as I told, boundary wall, right. So boundary, it's clear, it can be real or it can be imaginary. But when I talk about wall, so we generally have two types of walls separating system and surrounding. We have two kinds of walls separating system and surrounding. One is the adiabatic wall and other is the diathermic wall. Other is the diathermic wall. Now what is the reason when I say adiabatic? Adiabatic means it will not allow the exchange of energy. That means suppose I have this beaker and in beaker I have water, and I say that this wall is adiabatic. So what do I mean by saying adiabatic? Adiabatic means it will not allow the exchange of energy. It will neither allow the energy to come in and it will neither allow the energy to go out. So that means no energy exchange is going to take place in case of adiabatic. But when we talk about diathermic means energy exchanges can occur. Energy can also go in and energy can also go from the system to the surrounding. That means energy exchanges can take place. So that is called as diathermic wall. I think it's clear that when we are talking about boundary, it is just a separating surface that separates system with the surrounding. It can be real or imaginary, and as far as the wall is concerned, we can have the adiabatic wall which will not allow the energy to go in or out from the system, and diathermic which will allow the energy to flow in or out, right. So we have these things. Now we have like we did system, that system is a part of universe which is under investigation. So it is not concerned, there is no only one type of system, we get to see different type of systems, and that is something open system, closed system and isolated system. So we get to see three types of system around. One is open, other is closed, and the third one is the isolated one. See, I am just going to explain you with example. Suppose I have, you can say, I am going to draw a figure here. Suppose I have this container, and in this container I have water, right? I start heating it. So what will happen? It will form vapor, and the vapor will just go out into surrounding. Vapor will just go out from the surrounding. So that means this kind of system is exchanging energy as well as it is exchanging matter with the surrounding, because energy is also going out and even the matter, that is the vapors are also going out. So we say this kind of system as open system. See, once again, see, we divide system into three categories on the basis that whether they exchange heat or matter with the surroundings or not, right? So our first system is the open one. So as I told you, I heated it, vapor just, they are rising and even the energy is going out, right? And that means it can exchange energy as well as matter with the surrounding. So any system which can exchange both the things is considered as an open system. Now, what is the closed system? Again, I am going to heat this kind of flask. Suppose I have a container and I have water in it and I am heating it. So what do I get to see? And what I am doing, like I am just closing this upper surface with a lid. This is my lid, right? And I am heating it. So that means vapor are rising, but the vapors are not allowed to diffuse outside. Vapors cannot move outside. That means matter cannot be exchanged with the surrounding, but energy can. That means heat can flow out of this lid, but matter, that is the vapor, are not able to go outside. So this is what is the closed system. So closed system is that which can exchange energy but definitely not matter, right? Now the third one is the isolated system. See what I am going to do in the same way. I am just going to take a flask with the water. This time what I am going to do, I am just, the flask which I am taking has adiabatic walls. And you know that what are adiabatic walls? Which do not allow the exchange of energy, neither to come in nor to go out. And I am closing this lid also and with the same adiabatic substance. So what is going to happen? When I am going to heat it, it will form vapor. When I am going to heat it, it is not going to allow heat to come in. It will not allow heat to come in, but still we can found that we know that some of the surface molecules which are more energetic has the capability to diffuse up and form vapor, but still it is closed with a lid. That means the vapors are forming by water itself, not on heating by itself, right? But the vapors are not allowed to go out because it is covered with a lid, and that lid is adiabatic, which do not allow exchange of matter nor energy, right? So that means isolated system is that which is neither going to exchange energy or matter with the surrounding. This is what we have, three types of system. We are going to use it in the chapter, because I am going to tell you that this phenomena occur in an open system, this phenomena occur in a closed system. So you should be well versed that what actually is the open or a closed system, right? So open system is that which can exchange energy as well as matter. Closed one is that which can exchange energy but not matter, and isolated cannot exchange either neither matter nor the energy. Next we have is we have state of a system. We have state of a system. So when I say state of a system, it means the existence of system, that how it is existing. Existence of system when its all observable properties have definite values. As you know that like if I have a temperature below 0 degrees Celsius, that means the substance is going to exist as ice, right? So that is a state of water, you can say that. What is the state? It's obviously a solid state. So that means state of a system is a state out of solid, liquid or gas, that in which state the substance is going to exist, the condition being that its observable properties should have definite value. Because when the substance exists as solid or liquid or gas, it possesses the observable properties possess the definite value. So this is what is the state of the system. And those properties, these observable properties which have definite value or which just indicate the state, they are something called as state variables. They are called as state variables like temperature, pressure, because these are the factors that affect the substance to exist as solid, liquid or gas or whatever state, right. So this is these properties which actually guide the substance to exist in a particular state, or which are responsible for a substance to exist as solid, liquid or gas at particular conditions. They are called as state variables. So this is what we have, state variables, and this is what we have, state of system. Now see, we have one more term, that is macroscopic properties. We have macroscopic properties. Macroscopic properties are actually those properties which arise due to bulk behavior of an atom. That means that property doesn't depend on one atom or two atoms, it depends upon the whole atoms which are present in that system. So which arise due to bulk behavior. Which arises due to bulk behavior. That means which arises due to the aggregation of many particles or many constituent particles which are present in that system. So that constitute macroscopic properties. These macroscopic properties are classified into two categories. One is the extensive property, other is the intensive property. One is the extensive, like macroscopic property can be extensive and macroscopic property can be intensive. Now what is the difference between them? See, I am just going to explain the difference with an example. Suppose I have a container and in this container it is full of water, right. So let's say the mass of water is m and the temperature is T. Now what I am going to do, I am just going to divide this beaker into exactly two halves. Now, what is my mass? What is my new mass? Obviously, it is, because it is exactly halved, so its mass is exactly halved. And what about temperature? Does the temperature is also going to be halved? No, temperature is going to remain as such, T and T. So what you observed in these properties, as we know, mass and temperature both are macroscopic properties. So what difference do you get to see in both? That the mass became half when you just divided into two parts, but the temperature remained the same. So we have certain macroscopic properties whose value depend upon the amount of substance. As you saw that the mass actually depend upon the amount of substance, right. So that means the mass of the substance is extrinsic properties. So all those properties which depends upon the actual amount of substance which is present in the system is called as extensive, right, like mass, volume, so on. And when we talk of intrinsic property, their value depend upon nature, not amount. Depend upon nature, not amount, like temperature. So what happened when you just exactly half the beaker into two parts, the temperature remains constant because it depends on the nature of the substance, not on the amount of the substance. So that means our macroscopic properties can be extensive as well as can be intensive, right. Means they can exist as extensive and there are few properties which exist as intensive. Now suppose I say I have a A property which is extensive in nature, and I have B property which is also extensive in nature. I am going to take the ratio of these properties. So A by B, that means extensive property to extensive property. So what result we are going to get? The result will be obviously intensive. So keep in mind, this is very important, the ratio of two extensive property is always intensive. The ratio of two extensive property is always intensive, right. Suppose I have molarity. This is an example I am illustrating. What is molarity? It is number of moles divided by volume of solution. So when we talk of moles, so what is it, extensive or extensive? Obviously mole, when I say 4 moles, then we are counting the amount of substance, then only we are saying 4 moles. So that means mole is an extensive property. Right, and volume again extensive, because volume occupied by the 5 moles is different and the volume occupied by the 10 mole is going to be different. So it depends upon the amount. So again it is an extensive. But the result what you get, molarity, is definitely intensive. So keep in mind the ratio of two extensive property is always intensive. The ratio of two extensive properties are always intensive. So this is what we have: state of a system, we have macroscopic properties, extensive and intensive. So we have just left with few definitions more. One is state function. What do you mean by state function? See, that property is called as, like all the properties, we are talking about all the properties, right? But out of all properties, the properties which depend upon the initial and the final state and doesn't depend that how that state is being achieved is called as state function. For example, if I say I just want to climb stairs, I want to reach on 10th stair, right? So whether I go by foot or whether I like fly and go, so that means I just want to reach at 10th stair, and once I am there on 10th stair, so that means I am not concerned that whether I have you can say come up with what facility, right? Whether I have walked up or whether I run, and that we are not concerned with that. The concern is that I have reached on the 10th stair, right? So that like those property which depends upon the initial and final state and independent at how that state is achieved, that is called as state function. So state function is an important function because when we are going to start with the you can say more topics, we are going to know that whether this property is state function or not. So if it depends upon the mechanism through which that state is achieved, it is not a state function, and when it is independent that how the state is achieved, it is a state function. So this is what we have is the state function. Now we have different kind of processes occurring. We see different type of processes occurring in nature. So what kind of process do you get to see? We see isothermal process, we see adiabatic process, we see isochoric process, we see isobaric process, and we do see reversible and irreversible process. So that means there are many processes which are occurring in nature. So let's discuss them. One is the isothermal. So isothermal process is that which occur at constant temperature. That means the process in which the temperature is going to remain constant, that is called as isothermic process. And when we talk about adiabatic, we already did here adiabatic, this one. No energy exchange take place. That means energy is going to remain same. Energy is going to remain same. That is an adiabatic process. Isochoric, process occurring at constant volume. Isobaric, process occurring at constant pressure, right? So now we are concerned with reversible and irreversible process. So what is reversible process? See, I am just going to state with an example. Suppose I have this cylinder in which there is a gas and there is a piston, right? And here on the handle of piston we have pile of sand. Now what happens that the pressure exerted by the piston due to the pile of sand is just balanced by the pressure offered by the gas. So that is why piston remains still. That means it is not moving down, neither it is moving up. But when I am going to remove, suppose I say I am removing 1 or 2 particles of the sand, that means this pressure is going to be less, right? So internal pressure is going to increase, so the gas will expand. Gas will expand. Now again I am going to replace, like I just took out few sand crystals, I am going to put them again back. Then the piston is again going to move down. So this is what is the reversible or irreversible process. The reversible process is that in which you can say the process can be just reversed under the given set of conditions, and irreversible is that which can't be reversed under the given set of conditions. That means once it has happened, we can't reverse it, right? We cannot you can say get the reactant back. So that is something irreversible process. And one more thing, for the compression to happen, like we can have compression, we can have expansion, right? So we have the criteria, like for the compression to happen what should be there, and for expansion to happen what should be there. So if we want that a gas should expand, right? If we want that a gas should expand, then our external pressure is obviously, that is the when it is going to expand, P internal minus dP. That means the change in pressure is less and internal pressure is more, that is why gas is expanding. But when we talk about compression, so that means P external is P internal plus dP. That means the pressure is, like when we are talking about expansion, then it is plus dP, because internal pressure is more than the external. So when we this add up, this becomes more than the external. But when it is compression, it is less than this. So that means the result is going to be less than this. So as a result, the gas is going to contract, piston is going to move down. So that is how the compression is going to happen. So this is what I have told you, almost all terminology which is involved in this chapter. Now we are going to start